Welcome! In this series of short videos, we will look at topics common to both the PowerBasic console and Windows compilers. Today we will look again at a library of array functions by adding the ability to do indexed array searches. In this series of videos I'll be covering the creation and use of libraries. So you might ask, why use libraries? Why not just write code whenever you need it? Well, if you're writing a lot of applications, having common libraries that contain functionality that you use often will save you time, both coding and testing. It will also make your code more readable and therefore maintainable, which is always a good thing. I had intended to make the library array videos a two-part series, but we're now going to do a part 3. What we're going to cover today is comparing two arrays, looking for missing entries in the second of the two arrays, and reporting just how fast we were able to do that. So before we start comparing arrays, we will first need some data. We're going to reuse one of the programs we wrote before to generate some random data. There are 4 pieces of key information in this code: the maximum number of records that we wish to generate, in this case 20,000, and a date range for the dates of birth between 1950 and 2008. And we're going to produce an output file, which will be a CSV file called test_datafile.csv. The generate data application is within the generate data folder. If we try running our generate data application now, it will run through and create 20,000 random records for us very quickly. So we now have in our folder a test_datafile.csv. As you will see from this file, it contains randomly generated information on people's names, genders, date of birth, address, city, region, postcode, telephone numbers, emails and ages. And there are indeed 20,000 records in our file. So now that we've generated one file, I'm going to copy this file and then delete some records from it. So we have renamed the copy file test data file other. If we open this file up, and we will delete the last 6 records from the file. So we now have 2 very similar files, both with around 20,000 records. Our task in today's video is to compare the original file, the main file, with the other file, and report on the number of missing records. We're going to initially do this in the standard way to see how long it takes, with 2 nested for next loops. And once we have completed this, we will then do an index search. So let's have a look at the code. Here is the template of our application. At the beginning we have our libraries: the common display library, the file handling routines library, the array functions library, and the PB sorting library. We're going to be using the PB sorting library in order to do our index searches. And we have our 2 files, the test data file and the test data file other. In the PB main function, we're going to be calling a subroutine to search out the differences between these 2 files. So we will pass those as parameters to the function. If you have watched the previous video, the next bit will be fairly straightforward. We need to compare the 2 files and report on the differences. So we're going to set up 3 arrays. One for the main file, one for the other file, and one for the report of what the differences between the 2 are. Now that we have the array set up, there's some more local variables we'll need to set up to keep track of the delimiter of the files, the unique field name. As we're going to be comparing 2 files, we need to know which field within each record of those files is the common field, the one that uniquely identifies an individual record. In this case, we're going to be using the email column. And as we're going to be running 2 different versions of this program, one to do a standard comparison and one to do an index search, we'll want to know how long the application takes to run. So we're going to set up a timer at the beginning of our application so we can determine how many seconds it's taken to run each version. So there are our local variables. A delimiter, our unique field name, a variable to contain any error that occurs, a comparison type. Today we're just going to be looking for missing records. Dimensions. Today we're only going to be comparing two one-dimensional arrays, but in future videos we may be doing multi-dimensional arrays. So we'll prepare the code to be aware of how many dimensions the arrays actually have. Next, we have to load both of the files into the arrays. This is using the code we did in the previous video. We're calling the read the file into an array function. This exists within our file handling library. It will load the main file into the main array and the other file into the other array. As long as both of these functions return true, then we know all our data has been loaded. Now we're ready to compare those two arrays. We can define the name of the unique field name. In this case, the unique field name is called email. We're setting delimiter to a 0-length string. This is because the files we're reading are CSV files, and we're making use of the special functionality of the parse command to handle CSV files by giving it a 0-length string. It will then remove double quotes from either side of the data. We're setting our error to be an empty length string, and a comparison type is missing. We're looking for missing information that differs between the main file and the other file. If the record exists in both files, then it's not missing. If the record exists in the main file but not in the other file, then that's an entry that is missing. And finally, we're working out the number of dimensions in the main file by using the array attribute command. That command will return the number of dimensions. In this case, it will return a 1 for a one-dimensional array. We then populate a timer. This is a number of seconds since midnight. At the end of the process, we will check the timer again and report on the difference between the two. So we're going to create a new function to do our index array comparison, passing it quite a number of parameters. First of all, the three arrays, the main array, the other array, and the reporting array, the details of our delimiter, our unique field name, the comparison type we wish to do, a variable to pass back to us if there's an error, and the number of dimensions in our arrays. We will create this function in a moment, but let's just push on and complete the logic in this function. Having compared the two arrays, we'll then want to save the report to file. So as this is a single dimension string array, we can use the array dump function. So we will pass it a file name to save and the array we wish to save. And we're going to report on the duration by subtracting the current timer from the timer we stored at the beginning of the application. And that will tell us how many seconds the entire application took to run. So next we'll have to create this new function. But before we do that, we'll complete one or two of the constants at the beginning of our application. We need to give a name for the file that will contain any missing records. And as we're going to be doing an index search at one point, we want to set up some variables for that. At the moment I'm going to leave the index search constant as false. We'll come back to these three constants later. So we're going to add a new function to our PB array functions library. This is the new function called index array compare. This will be very similar to the array compare function we wrote in the last video. This will take in a number of parameters. It will take in our three arrays, the main, the other, and the reporting array. It will take in our delimiter, our unique field name, the type of comparison we wish to make, the error should there be one to be handed back, and the number of dimensions. So when we're doing this type of comparison, we're taking all the records one by one in the main file. And for each of those records, we'll be scanning through the other array to see if there are any matches. So we're going to have to create some local variables to keep track of this, so we can do our nested for next loops. So we're going to use a main row variable to keep track of the row number we're in the main array, and a main total rows for the total rows in the main array, and exactly the same type of variables for the other array. Again, we have the str unique field value, which is the value of the unique field in the main array. as we will be searching out the actual email address of the user to see if that entry exists in the other array. I've added two more variables for the other array, a start and an end. These are the start row number and the end row number. In the first time we pass through this application, we're going to be doing a scan from the beginning of the array to the end of the array. So as we know there are around 20,000 records in the array, it will be for next loop from between 1 and 20,000. This will change when we do our index arrays, but I'll cover that when we come to it. Next, in common with many of these functions and libraries, we need to do some error handling to make sure the data that has been passed to us in parameters is correct. At the moment, this function is only going to be handling missing data. So if we pass anything else in the comparison type, it will pass back an error message. Also at the moment, we're only going to be handling one-dimensional arrays. So if the number of dimensions is anything other than 1, again we will pass back an error. As we did in the last video, we're going to be handling data into a reporting array. And rather than redimensioning this one row at a time, we're going to redimension it in blocks. The array block addition constant currently has the value of 1000. So each time we need to add to this array, we'll be adding on 1000 records. And at the end of the process, we'll trim the report array to get rid of the unnecessary rows. And in here, I set it up to handle more than one dimension. This is basically a cut and paste job from the previous version of the code. Next, we're going to find the unique field. As we'll be passing the email column header, we need to make sure the email column header does actually exist in the main file. This will return the column number. If the column number returns 0, it means it has not found the field and it will return an error message. Next, we're going to populate some of the local variables we set up at the beginning of the function. First of all, to get the total number of rows in each of the arrays. This is using the ubound command. The ubound command, with no optional parameters set, will automatically look for the total number of rows in that array. And for the other array, we're going to be setting the start initially to be the first row and the end row to be the total number of rows in that array. I'm putting a line of code in here to test the index search constant. If it's true, we're going to be doing an index search. We'll do that second, so we'll leave this bit blank at the moment and fill it in later. Now we get to do our actual search. So this is going to be two nested for next loops. The first loop is on the main array. As we'll want some kind of feedback to the screen, because this routine is going to take a little while to run, what I'm going to do is put something out on the screen for every 1000 records processed. This can be quite easily done using the mod function. Main row is a variable that reports the record count. We're using the mod command to divide it by 1000, and if the remainder equals 0, then we're on a 1000 record boundary, and we can report on how many rows we've processed. If we reported on every single row, the application would slow down because it would spend most of its time reporting on the screen. So this is an easy compromise to at least give you some feedback that the program's actually doing something. Next, we want to pick up the unique field value from our main array. We're going to make use of one of the functions we've got in our library, the arrayGetUniqueFieldValue. This will return the actual value in the column of the main array that contains our email address. And again, I'm putting another hook in here for the time we're going to be doing index searches. So now that we have the email address in the first row of the main array, we now have to search all the records within the other array to see if we can find a match. So we will first pick up the unique value in the other array of the email address. And next we will compare the original main file unique value against the other array's unique value. If the values actually match, then we're going to set this variable, longFound, to be true. And at that point, we know we found a match, therefore the record cannot be missing, therefore we can exit the for next loop. And having exited the for next loop, we'll then move on to the next record in the main array. But before we do that, if we have found there is a missing record, we'll want to add it to our reporting array. and we don't have to look any further in the other array because we have found a match. Otherwise we would continue until we get to the last record in the other array. So once we have completed looking at the other array, we can then test the value in long found. If the value is false, then we did not find a match. So we can report on the data that exists in the main array that does not exist in the other array, using another pre-built function in our array handling library, add to array. So having gone through those two nested loops, we now have a certain amount of data in the reporting data array. As I said earlier, this array will be bigger than we actually need, so we need to truncate the array to hold just the data we've actually stored. So we will copy a piece of code we had in the last video to truncate the array to the data actually stored. For a one-dimensional array, this is remarkably straightforward just by the use of the readInPreserve command. For a two-dimensional array, I've written a small function that will trim that quite happily. So that should complete all our coding for the first run of our application. All we need to do now is to take the two data files out of the generate data folder and copy them in to the main code folder. So if we run the application now, it will load both of those files into arrays, make a comparison and report on anything missing. So now that we've copied both of those files into the main code folder, we're ready to run our application. So both files have been loaded and are now being compared. As you will see from the row count, the application appears to be running reasonably quickly. It's reporting as each 1000 records in the main array have been processed. We'll speed through to the end of the run. And there we have our application completed. It is completed in just over 30 seconds. 30 seconds is not an unreasonable time to wait for this kind of comparison. We are, after all, comparing two arrays, each of which is around 20,000 records. However, if the arrays we're comparing were 200,000 records, it would take considerably longer. So what we'll do next is we will do an indexed array search, and we'll compare to see how much faster that actually is. So let's make the changes to our code to turn on the indexing. First of all, at the beginning of our code, we will change the index search constant from false to true. And if we have a look at our library function, the indexArrayCompare, there are some changes in here we'll need to make as well. What we're going to do is we're going to create an index. We will first sort the data that's in the other array, so it becomes in effectively alphabetical order for the field we're using to do our comparisons, in this case the email field. And we will store the index of when those begin and end in a separate array. This is our index array. Since we know the email addresses all start with a letter, and the letter is between the letters A and Z, and there are 26 letters in the alphabet, we're creating an array of 30 elements, which is more than enough to store one record for each letter. We are storing two elements of that. The first element is the row number which the letter A begins at, and the second number will be the row number the letter A ends at. And then for the next entry in the index, it will be for the letter B, and so on. And we've created a single variable, strindex, to hold the first letter. And long slot will be the pointer towards the index array. So if we look further down our code, the one thing we'll need to do is we'll need to sort our other array. So we've set a section of the code up already to say this is where we're doing an index search, and this is where we want to sort the other array. We can make use of the function ArraySort within our sorting library. This function is ideal for what we want to do. We will pass it the name of the array to sort, in this case, other file. This is a string sort. We're passing it the column number of the unique field. This is the email column. We're passing it the delimiter. We're passing that we want it sorted in alphabetical order, ascending. We have an error variable which it may pass back, and we want to keep the headers where they are. On completion of this array sort command, the strOther file array will be sorted in alphabetical order based on the email address. I'm going to put an array dump command in to dump this array out to a file just so we can have a look at it. However, it isn't necessary to actually dump this array out for the program to work. This just gives us some debug information should something go wrong. So if we try running the application now, we can have a look at that sorted other file. And there's our application completed. Now we can have a look at that file. So there is our sorted other file. If we open that one up, we'll see that all the names are sorted alphabetically based on the email address. So this allows us to see that anyone whose email address starts with the letter A will be starting from the first record. And further down the file, the B's will start after the A's. Therefore, rather than having to search through the other array for all 20,000 records, we only have to look through about 10% of the file. This should make the index search very much faster. So now that we have the other array sorted, we'll now have to build our index. So we'll need a function to index an array. This will take 3 parameters. We need to give it the name of the array that needs to be indexed. We need to give it the name of the index to contain the index data. And we need to give it the unique field we're actually indexing on. So this is another new function for our array functions library. This function works on the assumption that the array has already been sorted. It will go through each record within the array. It will then pick up the unique ID based on the field we have passed it. In this case, this is the email address. It will then pick up the first character of that email address and it will force it to lowercase. If there is no email address, then it will iterate to the next record. And then we're using the ASCII command to work out what the number in ASCII of the first character is. We're subtracting 96, so the letter A would come out from this algorithm as being number 1. This will be the first slot in our index array. So this for next loop will step through this array until it finds the first email address that does not start with the letter we're dealing with, in this case A. Then it will save the information into the index array for both the start and the end index. So now that we've finished building the index for our array, we can make use of the data within it. Further down our array compare function is another hook for index searches. In the previous version of this code, we were running from the first record to the last record in the other array. We're now going to amend those values. First of all, we get the first character of the email address and we convert that to lowercase. We store that in the str index variable. And then using that information, we work out which slot in the index array this will exist in. So if the email address starts with the letter A, this would return the value of slot number 1. We can then populate the other start and the other end variables based on the data within that index. So rather than searching from record 1 to record 20,000, for the letter A, it will probably start record 1 to record 2 or 300. So this should speed up our search considerably. Before we run the code, let's have a look at the report data that the last run actually produced. This produced a missing records CSV file. This file has in it the 6 records we deleted from the end of the other file. I will rename this file so that we don't lose it when we run the program again, so we can compare these two files to make sure we're getting the same results. The first time we ran the application, it took slightly longer than 30 seconds to run. So if we recompile our application now, just to make sure it compiles, and if we run the exe again, as you will see, the application now runs considerably faster. It's now running in just over 2 seconds, as opposed to the just over 30 seconds it took before. But have we got the same output? there is our missing records file that has just been produced. And it has in it 6 records. If we look at the original file, it also has exactly the same 6 records. So with a small change to the code, by means of which we actually sorted the other array and then indexed it, we have now managed to speed up our search considerably. Now that it runs in 2 seconds, running against an even bigger file would give us an even bigger difference in time between the index search and the non-index search. So as you will see, creating an index on one of these arrays in order to do your searches faster does make a considerable improvement on the efficiency of your code. But that's it for today. Thank you for watching.